Okay, in today's video, what I want to talk about is the MAPC. So if you recall, well, I'm not sure if you've been through the portion of the training where I talk about building cams and stuff of that nature, but this is kind of building off of that. If not, if you haven't been through that, rest assured that will be covered. But the MAPC itself, generally speaking, you've seen me use a scaling for the slave scaling and the master scaling as a 1-to-1 ratio. Generally, you don't see me put a tag in there. You see me just throw in a raw number. Generally like a 1-to-1 or 1-to-2, whatever the case may be. So far, we really haven't touched on that, and so this is what this video is about. And then how does it actually affect the servo's motion, right? So first and foremost, what I want to illustrate is you don't have to name it. You can name the tag whatever you want to name it. The real important part of the tag that you need to know is servo tags and stuff of that nature need to be, if they reference anything to do with positioning or velocities or scaling or anything of that, they need to be reals. They don't need to be dense. A lot of times they won't even be accepted. So just know if you have a error or a fault, or not a fault, but it won't be accepted, that check your data type. And if you accidentally made it wrong, don't worry about it. Just throw the tag away, make a new one. Change the name. If you're really adamant about what the tag's name, just like take out a space or something, or add an underscore or something, kind of help you out. So anyway, so both of these are done. I just simply named them scaling, slave scaling factor, and master scaling factor. Okay, so real quick, I'll show you that exactly how this works. I have a trend running. Right, so that trend is actually running and it's not doing anything. What I will do is, and I have the servo, this is the Servo Motion Mastery, the original program that we had, that we developed. So this is with real world inputs and live devices, so it doesn't have, we do have actually, everything is hardwired. So there's no virtuals. I mean, there's a virtual in here, but that's a virtual axis for the main motion control for that example. So for that matter, we will be using the virtual in this as the master axis that we're following, and the slave will be the actual servo drive that we have. Which again, going back to kind of touching back on that, is this the MPL motor that we've had in the system since we started. So real quick, I'll show you the natural 1-to-1 factor that I've been talking about that you've seen throughout the whole training. So what I'll do is I'll start the cam. Okay, so I'll start the cam, and what I'll do, sorry about that little pop-up. Every now and then I'll get a little pop-up when I'm. Anyway, so what I'm gonna do is actually start the cam right now. And I've started the cam, so that's actually got the motor running because of the way I have the virtual running. So we'll open up, and you'll see now the nice smooth, and granted this is velocity, but the nice smooth transition that the cam is actually running. And if you wanted to look at positions, you can kind of see this really small position is running. So I wanted to show the cam itself, in a nice smooth increment, so you can see exactly how that's working. Now I'm not going to stop the trend. What I want to do is actually stop the MAPC. So I'll push the stop button right here. I'll stop the MAPC. You noticed everything stopped. I'm going to change the scaling now. Now I'm going to change the scaling on the slave to show you that the slave, changing the reaction that the MAPC will have, changing the slave, and I'll change it to 2.5, and we'll do that to begin with. So now the scaling of the slave to the master is a 2.5 to 1. right? So basically, you know, or we can even put it at 3. Let's do 3. So that way it's a 3 to 1, right? Okay, so now let's start it up. Let's start the motion axis position cam again, and let's actually see what it does. And we'll go back to our trend at that point. Okay, so now we're running, and you see a lot different reaction, right? The motor is actually accelerating a lot more rapid now. And if you looked at the position cam is, again, it's a little bit bigger. You know, you're seeing it's really the same profile, but you see the more definite how fast it's actually moving based upon the velocity. Again, that's the real important thing. And torque is somewhat a factor, I would say, but really you're getting you really want to watch your velocity. So that's really what the key to this is. Okay, so that was with a scaling of 3 to 1, right? So let's actually take that back. Let's go to a 1, and then on the slave, and now let's reverse it. Let's actually let's change the master to a 3 to 1. So we're going to do a master 3 to 1. We're going to start it now, and then you see how that really does affect the change. Really, that's the velocity again. You can see that the cam is still doing that profile. This is the position. Again, that's why it's kind of hard to illustrate what the position is doing. The velocity again is really smooth on this. So the motor shaft is barely moving at this point. So so let's take that up a little bit. So if we wanted to, we'll stop it again, and let's up the scaling from the slave to a 5, and let's keep the master at 3. Okay, so we're going to do that and see how that affected the cam now. So what we'll do is we'll start the MAPC again, and now we'll go back and look. So you see now we're starting to get a reaction out of it, but what happened is it's more spread out because we've actually got a longer distance that we're required. We're basically widening the distance between the movements. So I'll show you that too, as the positions. So you see how wide that gets on the positions. So real quick, what we'll do is we'll stop it again, and I'll take it even wider than that. So let's say 10. Let's say a 10 and a scaling of 5. Right? Okay, so now we'll start it again and see what that does. Nice and smooth again. See how that happens? So basically all we're doing is we're kind of slowing it. We're making it wider with it when what we're doing. So let's stop it and take this back to 5, and let's take this up to 10. See what that does. So now we're basically in the ratio, you know, it's almost 2 to 1. So let's see what that does. So we stop, we start it back. Okay, so that's a 2 to 1 ratio, right? But the difference is the same. That's the cam profile that we're currently running, and it actually is spread out a lot more. So if you notice, if I took this back to a 1 to 1, it's the same profile. So I'll start that back. It's the same exact profile, except it's shorter. You see how short that is? So if you want to get the width out of it, all you do is change the scaling. But there's two different things. You know, you can make it actually index higher and have a different movement, or you can widen it out like the distance. So widening out the distance would be the master. If you want to bring the scaling higher, like more velocity, then you can change this, and we'll do the 3 to 1 again. That way it kind of shows it. Okay, so now we'll start it back. So you see it's short and real rapid, but you get a lot more velocity, and you still getting the same cam because this is still the distance of the master is still a 1. So you're getting the same thing, right? So now if we took that and took that scaling to a 3, we should get almost the same effect, right? Okay, so let's actually start that again. We're going to get that. See, now we're back to like a wider but less velocity. So it's a nice smooth transition when it's running. And again, the position is doing the same thing. And the only reason it's running downhill is because of the fact of the way the cam is written. This profile, and again, that's down here. You'll see that later in the MAPC that we're doing, or the MCCP. So that's something you'll see then. So don't worry about that. We won't talk about that in this video. What I wanted to talk about and highlight is the scaling. So if we went ahead and threw that back to a 1, or let's just keep that at a 3, and then we'll put this back at double, or 3 times basically what it used to be. So what we should have now is a wider profile, and then a lot the same velocity we used to have as a 3-to-1, but wider. See, but it's going to be a lot wider. So you see it almost looks bigger, but it's the same exact thing, except it's just wider. So now instead of nice little tight loops, you have, so that there's a distance in the master, because the master is actually, the position of the master is what you're referencing and what you're telling the slave to do. So when you scale it higher, that's when you're going to get a different reaction from that. So what I wanted to do is again kind of show you the differences of what could happen and what will happen when you're actually changing the slave and the master, and kind of just illustrating the difference between the two, right? One changes the width of the cam, and the other one changes basically the height of it, or the more dynamic the cam can be, I should say. So, and with that, you still got position. You see the position loop is a lot greater too. So, because our growth is there, right? So we have basically a 3-to-1, but it's still spread out. So if we took this back to a 3-to-1, we started it back. See, it's still the same thing, but a lot tighter loop, right? So let's take that back. Let's take it to a 9, or whatever you want to take it to. As long as the ratio is still 3-to-1, right? So you can put it to whatever you want to. In this case, we'll do 9 and 3. So again, we'll cut that back on. And you'll see the same exact thing, except it's a lot wider now. It's not such a tight profile, and that's just running that cam different, So I just wanted to kind of highlight that. We'll stop it. So you'll see the cam. That's the cam it's running. So it's just doing it in a wider profile, and the scaling has a great effect on this. So just understand that you can influence MAPC by doing the scaling. Don't necessarily, unless you have unless you do have your positioning correct, is your positioning going to follow basically what you want to. That's why you choose, when you're choosing to do positioning, when you're like building a cam and stuff, you really should use this MCCP, which again we'll talk about later in the training. So don't fret. We'll cover that. So don't necessarily assume that you can just change the scaling here and accomplish a goal. You can in some instances if the thing, like if you're dealing with a rotary and the same position happens continuously, that's fine. But to make sure you stay in perfect harmony and perfect positioning, and the perfect velocities and everything like that, you definitely want to use the MCCP for positioning. The MAPC is again a position, and then you can use your scaling for you know, if you want to widen the cam, or if you want to have better velocity or quicker. You know, that's kind of what that's there for. You know, there's several different applications you can use both of these for, or you can use them together. Generally, they are used together, but just to kind of highlight the fact of the scaling factor is what we're talking about here. So, you know, this video can leave a lot of questions out there, but please follow through the training, go through all the training, and all of these questions will be answered throughout there. So don't worry. Again, I kind of jumped to using some of the programming that I did in the later modules, but just be, you know, just be patient. You'll see it. You'll definitely go through it, and you know, and always feel free to reach out if you have any questions or anything, and I'll be glad to help you out. Okay, thank you, and keep on with the training, and thank you for the support.